In this video, we'll solve question paper 6.3 of 6020 chemistry, 0620 chemistry, that is IGCSE chemistry of examination series October-November 2023. So let's start with question 1 here, and the question 1 says, hydrated aluminium chloride is a white solid. When heated very strongly, hydrated aluminium chloride produces steam, hydrogen chloride gas and aluminium oxide. Hydrogen chloride gas is toxic and aluminium oxide is a white solid. A teacher heats a sample of hydrated aluminium chloride using the apparatus as shown here, and you can see there is a tripod stand. A heat can be given here with the help of Bunsen burner. Here is an apparatus and the hydrated aluminium chloride solid present inside the apparatus. Now the sub question A says, name the item of apparatus labeled A. Now A is the apparatus used for heating, and that is called crucible because that's made of clay, which is generally used for heating any solid substance at a high temperature, because this crucible can withstand a high temperature without getting affected. So that's called crucible, and let's write that here, crucible, CRU it is. So here crucible is named A. Explain why this experiment should be carried out in a fume cupboard. Now if we are talking about a fume cupboard, that's generally done when a toxic gas is produced during the experiment. So here if you look at hydrated aluminium chloride, when heated produces what? Steam, hydrogen chloride gas and aluminium oxide. Now this is a solid, that doesn't make any difference. Now hydrogen chloride gas is toxic, it's harmful, and that's the reason that we perform this experiment in fume cupboard. So we can write hydrogen chloride gas produced is toxic. It carries only 1 mark, so we don't need any further explanation, and that's how we write it in short, in just one sentence, that one of the product produced, that is hydrogen chloride gas, is toxic. Now the next is sub question C. It says the hydrated aluminium chloride has to be heated very strongly. Describe how a Bunsen burner is adjusted to make the flame as hot as possible. Now we can adjust the flame of the Bunsen burner, and how is that flame adjustment done? By adjusting the air hole of the Bunsen burner, which is present at the bottom. Now you might be knowing that the Bunsen burner is something like this. There is a hole here. So to keep it open fully, then the air entering, that is oxygen entering, will also be in good amount, and that will make the flame hottest. So what we can write is that open the air hole fully and adjust the blue flame. Now the flame should also be blue, because yellow and orange flame is not very hot, but the heat of blue flame is higher. So we always try to make the blue flame of the Bunsen burner, which is the hottest. Next sub question says, during the experiment the mass of apparatus A and its content decreases. The mass of apparatus A is crucible in which we have taken aluminium chloride and it's heated, and during the experiment the mass of the whole solid decreases. Explain why the mass decreases. Now as we know that during the experiment, when it's heated, steam is produced and hydrogen chloride gas is produced. Now both of these are gas and it escapes out of the open apparatus, and that's why the overall mass decreases. If we keep heat the substance in a closed mass, then the gas won't escape, and that's why the overall mass will remain same, but here the apparatus is open. So what we can write is steam and hydrogen chloride gas are produced during the experiment, which escapes out of the apparatus. That's why the mass decreases. So out of the apparatus, if it escapes, obviously the overall mass, the total mass decreases. So this is how we are going to write. A gas is produced and that leaves the apparatus. Next sub question says, describe what the teacher can do to be sure all the hydrated aluminium chloride reacts. That shows that after heating, no aluminium chloride should remain in the apparatus. It should fully change into aluminium oxide. That's what they're trying to say. That all of the aluminium chloride should get reacted to turn it into aluminium oxide, hydrogen chloride gas and steam. So if you want to ensure that all of it is reacted, what we need to do is, even after heating, it has cooled down, reheat it, keep on doing this till the constant mass of the apparatus or the constant mass of the remaining solid product is obtained. So what we can write is, keep reheating the solid. What are we heating? The solid in the apparatus. Keep reheating the solid till constant mass. That's how we describe it. Till constant mass means after every heating, we'll allow the apparatus to cool down and then weigh the mass. If we keep on repeating the experiment and after reheating and after cooling, if we get the same mass in the concordant heating, then obviously the heating is fully done, the experiment, the reaction is over, and that's how we conclude that all of the reactant has reacted. Okay. The next question says, in a second experiment, the teacher uses the apparatus shown in figure 1.2 to collect the water made. Now hydrated aluminium chloride is taken in a tube, sealed tube, you can see here, and the heating is done not in the crucible but in a sealed glass tube. Explain the purpose of the ice. Now here you can see that the gas produced is passing another tube, the waste gases escape out, and there is an ice outside these tube. Now the purpose of generally the ice is cooling down of the gas produced. So what is the gas which will cool down? That's the steam, because hydrogen chloride gas doesn't cool down and turn into liquid. So the steam will cool down, condense into liquid water. So explain the purpose of ice. So ice is generally used to we can write to condense the steam, condense the steam produced and change it into water, So this is how we say the ice is used to condense the steam to water. The water collected is not pure. Describe the test the teacher can do to show that the water collected is not pure, and state the results of the test if the water is not pure. So if water is not pure, how will we prove that the water is not pure? One of the best test to prove that water is not pure is either check its boiling point or melting point. But melting point I would say is difficult, because we need to first freeze the water and then measure the melting point or freezing point. Rather, it's very easy to check the boiling point. So I'll say that check the boiling point of water, and if it's pure, it's obviously going to boil exactly at 100 degrees. So you can write result: boiling not occurring at 100 degrees, So if it's not pure, if it occurs at 100 degrees exactly, it's a pure water. But here we want to prove that it's not pure, so boiling won't occur at 100 degrees Celsius. And you can see that here is the end of question 1. Let's go ahead and see what is question 2. It's a long process where you can see there is a series of steps to be done in the question 2. But let's start with question 2 reading. A student investigates the reaction between dilute hydrochloric acid and aqueous sodium hydroxide. The student does 2 experiments. Now there is a full experiment 1 and 2 steps given, but I'm not reading all of them because there is a long step. You can always pause the video and read the whole process. In short, I'll explain. There is a kind of titration going on between sodium hydroxide taken in burette and with the help of measuring cylinder, dilute hydrochloric acid is taken in a conical flask. The indicator used is methyl orange and the final burette reading for the color change is noted down. In the second experiment, you can see that before the titration is done, after adding 25 cm³ hydrochloric acid to conical flask, they've added 0.50 gram of calcium carbonate to the conical flask, allowed it to react, and then the titration with the help of methyl orange, the sodium hydroxide is done and the color change reading is noted down. So there are 2 experiments. So here are the readings for the experiment 1 given, the initial reading and the final reading, and you can see here it's 0.6 and the final reading you can say here is 19.2. So 0.6 and 19.2 for the first reading. So I'll write here for the experiment 0.9 and it's 0.6 and final burette reading is 19.2. Let's look at the readings of experiment 2. Initial reading you can see is 1.4. No, it's 1.5 here, so it's 1.8 here. So 1.8 is the initial reading for the experiment 2, and for the final reading you can see it's exactly 8. So we can write it as 8.0. We always should remember that the burette reading is always written at 1 or 2 decimal places, but you just cannot end up writing 8. That's wrong. We at least need to write it to 1 decimal place. Even if it's you add 1 more 0 here, it's not wrong. To be on a safer side we can add, but at least 1 decimal place has to be written. So to find the titer, that is volume of aqueous hydroxide used, we need to find out the difference, and the difference is 18.6 here, and you can say here is in 6.2. 6.2 is the difference for the experiment 2. So you can see the difference here. Experiment 1 required a very high volume of sodium hydroxide for the reaction, even more than double. If you compare, it's exactly 3 times. 3 times experiment 2. Experiment 1 required 3 times volume of sodium hydroxide compared to experiment 2. Okay, state the color change observed in a conical flask at the end in both the experiments. Now if we have used methyl orange, let's confirm what is the yes, methyl orange is the indicator used. So if methyl orange is the indicator used, and in the conical flask what have we taken? Hydrochloric acid. If hydrochloric acid taken in conical flask and methyl orange is first added to acid, so what's the color of methyl orange in acid? So obviously the initial color is red. Now on adding sodium hydroxide, if it changes exactly at the neutralization point, it will change to orange because it's methyl orange. So acid to base, so methyl orange, red to orange will be the color change. The C says when 0.50 gram of calcium carbonate is added to the conical flask in experiment 2, a gas is produced. Okay, calcium carbonate is added to hydrochloric acid. Now if a carbonate reacts with any acid, carbon dioxide gas is produced. So suggest the identity of the gas. We can write CO2, you can write the name of the gas, that is carbon dioxide, in words also. Okay, the D sub question, it says in experiment 2 the conical flask is rinsed with water, but the burette is not rinsed with water. State why there is no need to rinse the burette with water. Now the simple thing is that in burette we had filled sodium hydroxide and the volume and concentration, the concentration and the type of solution added to burette is same as experiment 1. So we don't need to wash it or rinse it with water. So we can say that same solution, sodium hydroxide with same concentration is used again. So same concentration is used again in experiment 2. So no need to wash it with or rinse it with water. Explain why the conical flask is rinsed with water. Now conical flask needs to be rinsed with water. The reason is that now the content of the conical flask might change, because in the conical flask we had added methyl orange also, and the color change was observed. We had added sodium hydroxide also. We need to remove all these particles of the reactants and products in the conical flask before we start the new experiment. So what we can write in short is that to remove or wash off the residue from experiment 1. Residue in the sense all of the substance which is used in experiment 1, all of that is residue from experiment 1. We need to remove it off before we start with the experiment 2. Okay. Next is the conical flask is not dried after being rinsed with water. State how drying the conical flask affects the volume of aqueous sodium hydroxide needed to reach the end point, and explain your answer. I'll say there won't be any change in the volume of sodium hydroxide required for the experiment. The reason being is that even if some amount of or some droplets of water stays back in the conical flask, still the number of molecules of HCl that we have added with the help of measuring cylinder will not change, and as the number of molecules of HCl does not change, it won't change the volume of or the molecules of sodium hydroxide needed for the reaction. So I'm talking about in terms of molecules, but if we want to write it in precise here, I can write it, it does not change the amount of hydrochloric acid. In short, because we can't specify the number of molecules, either we can write the number of moles. Yes, we can write that the number of moles. So we can write the number of moles or the amount of acid does not change due to the presence of water, and that's why we don't need to dry it. And so no change in the volume of sodium hydroxide required. I'm writing in short, sodium hydroxide required. So this carries 2 marks because 1 mark is for no change in the volume and the second mark is for the explanation. So let's go ahead with the next sub question where it says E1, compare the volumes of aqueous sodium hydroxide needed to reach the endpoint in experiment 1 and experiment 2. Now we have already discussed that experiment 1 required 3 times more volume of sodium hydroxide compared to experiment 2. So we can write it here that the volume of sodium hydroxide, you need to write it in words, but I am writing it in short. The volume of sodium hydroxide required in experiment 1 is 3 times more. 3 times, here also you can write 3 in words, not the way I have written. 3 times more then experiment 2. This is how we write. You need to write all this fully because as I don't want to waste time here, so I'm writing in short. Okay, let's go ahead with the next part. It says explain why different volumes of aqueous sodium hydroxide are needed in experiment 1 and experiment 2. Now experiment 2 we had seen that 0.50 gram of calcium carbonate was added to the HCl. Now if HCl reacts with calcium carbonate, some of the acid is used up and that's why it required less sodium hydroxide. So we can write that calcium carbonate neutralized, or you can also say reacted, neutralized some hydrochloric acid, and so it required less volume, less volume of sodium hydroxide. That's how we describe it. Okay, next part says calculate the volume of aqueous sodium hydroxide needed to reach the end point if experiment 2 is repeated with 0.25 gram of calcium carbonate instead of 0.6. Now if we make the calcium carbonate half, then obviously the acid required will be double. So what is the amount of acid required here? The volume was volume of sodium hydroxide required was 6.2. So make it double. So it should be 12.4. So what I am showing here is 6.2 multiplied by 2, that is 12.4. So 12.4 centimeter cube. Now it carries 2 marks, remember. So it's necessary to write the unit centimeter cube. 12.4 centimeter cube of sodium hydroxide will be required to neutralize the acid if half the calcium carbonate is added compared to earlier. Okay, the last sub question says describe how the reliability of the results obtained can be confirmed. Now if we are talking about the reliability, means how do we know that the results obtained are correct? So what we can do is repeat the experiment and find the average. Repeat the experiments and compare or find the average and compare the results. In the other words, you can say find the average also if you want to use it for the further calculation. But here if we are just checking the reliability, okay, we can just end up comparing the results. If the results are similar, that shows that our results are reliable. And here is the end of question 2 also.